Welcome back, everyone, to another episode of this series. Today, we are going to introduce ourselves to GeoPandas. And I assume that you already have it installed. If you don't, there is the link in the description that will take you to the official repository for this series. There is a Get Started section that will show you how to set up your Anaconda environment, which contains exactly the same packages as I will use in this and subsequent episodes. So just look at the Get Started series and set it up, and then let's go. So GeoPandas, if you have ever used Pandas, think of it like Pandas with a geospatial aspect added to it. To begin with, I have to import it. So usually, by conversion, you import GeoPandas as GPD. But you can import it as anything. Before that, I want to import OS. Usually, I like to put the packages that come default with Python on top before third-party packages come in. I will also need Pandas itself, even though I can do with GeoPandas, but I just want to use Pandas for that. So Pandas as PD. And I'll need some geometry objects to create what we call a GeoDataFrame, and I need that from Shapely. So I will from shapely.geometry import. I will import point. I will need the line, maybe the point for now, just the point. And I'll run this cell. Okay. So the first thing to do is to learn how to load and explore data using GeoPandas. Usually, if you have data like a shapefile or a GeoJSON or a GeoPackage, we can load it in here. But because we don't have one at the moment, what we will do is that we will load one of the data sets that come default with GeoPandas. When you install GeoPandas onto your system, it comes with some default data sets. So as you install the package, those data sets are also downloaded and stored somewhere on your computer, and we can access them. How we do that is you can create a path to it. You can also nest it directly, but I love to break things down. So that will be gpd.datasets.getPath. Inside here, we pass in the name of the data set that we want. One that we are interested in is the natural earth, one word, and then underscore low resolution. Just like Pandas, when you read data into a data frame, this one is read into what we call a GeoDataFrame. So you usually see GDF for GeoDataFrame, and that equals to gpd.read file. And then we pass in the path to the file that we want to read. And this read file can read all the file formats that GeoPandas supports. So you don't have to even specify an engine or a driver. It automatically knows that from the extension of the file, maybe. So we can view our GeoDataFrame by just calling it, especially if we are using a notebook. If not, you may have to print it. So this is the file, the details. So the natural earth low resolution data set is just data for the countries of the world. You can see the columns, the population estimate, the continent, the name, which is the name of the country, their ISO code, and then the GDP estimate. And of course, you know this multi-polygon. We have done geometries, how to represent vector geometries in the previous series. You can make reference to that if you have to. But you should understand this part, that this is a polygon for Tanzania, and Fiji has a multi-polygon. So that is it, how we load data. And if you are familiar with pandas, you can perform all the pandas operations on this one also. So if I go .describe, I will have the quick statistics of the data set. If I go .info, I will have this info about it. So all the things that you can do on a pandas data frame, you can do it here and check everything that you want to check. So for instance, the info let us know that whether there are some null values somewhere, but these are data sets. It doesn't have a null value anywhere. Okay, so that is how we load a particular vector data into a GeoDataFrame. If we print the type of GDF, I've been saying GeoDataFrame for a while, but if we print the type of GDF, I'm expecting it to be a GeoDataFrame. And of course, it's a GeoDataFrame, so it's a GeoPandas GeoDataFrame. And what makes a GeoDataFrame, or let me say what distinguishes a pandas data frame from a geodata frame, is the geometry column. At least I can say that confidently, because if you don't have a geometry column, then it is not a geodata frame. You can treat that and call it an ordinary pandas data frame. But once you have a geometry column, it becomes a geodata frame that GeoPandas can work with. There are other things that come up together to make a geodata frame, but I think the most important, if not the only one, is the geometry column. Now, if you want to explore this data set, it is quite easy. You can just call the .plot function on it, and this will plot the data set for you. So we can see here that is just a map of the world, countries. We can put in figure size here. This is just an introduction to the GeoPandas, so I'll not spend so much time in beautifying plots, but subsequent episodes will explore that in detail. But if I increase the figure size, I see that this is the map of the world with the countries in there. Okay. So you can plot it and see how your data set looks like. Another cool feature in exploring the data set is to, so let me give a comment. This is plot the data. But if you want to visualize it interactively, interactive visualization, then you have to call gdf.explore. And when you call gdf.explore, you see an interactive map like this that you can zoom in and out, and then you pan around. This is a map, an interactive map that you can perform all of those things on. But unless you enhance it, you cannot really do so much other than zooming in and out and panning. So we'll get into details for this one also when we get to that part of the series. But if you want to interactively visualize your data set, you just have to call the explore on it. So we've learned how to load the data and explore, even visualize it. The next one is how to filter and select data. It is just like pandas. We have simple filters, and then you can also nest filters or queries if you want it that way to get a particular result. And let me name this variable query. So let's just say that we want to get a specific country. Let me call GDF. And Fiji is the first one. So let's just say we want to fetch out only Fiji. For that one, we can say the query, and we call the GeoDataFrame, bring our pair of square brackets, and then we ask it where the column name equal to Fiji. This one is a very simple one. Just get us that particular entry where the value of the name column is Fiji. So when we inspect our query, we should see that only Fiji is returned. This is very simple and straightforward. If we also go to maybe continent, that was another column. If we choose Africa, then you see that all the African countries are returned. If we change it to, say, Asia, then you see that all the Asian countries are returned. Maybe we should start plotting this thing rather. Dot plot. And this figure size, I may need it. Let me copy this. Then these are all the Asian countries. We change it to Europe. And then we have the European countries in there. So this is just a very simple way of querying the data sets. You just have only one query in there, and then you get you get what you want. So I'll call this part the simple filter. But if you use the select by expression or the select by attributes, the select by expression, I think that is for QGIS, and the select by attributes for ArcGIS. If you use these two, then you know that we can perform complex queries than this. Sometimes you want to get a data or a subset that fulfills about 4 or 5 requirements. So how do you do that in GeoPandas using Python? That is also way easy. I'll create another code cell and then call this one maybe multiple filters or something like that. So let's just say that we want to get all the countries in Africa with a population of more than 20 million. So let me put that query here. Countries in Africa with a population greater than 20 million. So this one breaks it into 2 queries. First, the country should be in Africa, and also the population should be greater than 20 million. This is just more than a simple single filter. For those ones, how we go about it, let me call this one filtered. It's the same GDF, the same pair of square brackets, but because the filters are many, I would like to break them on separate lines. You can keep them on one long line. That will also work. Python doesn't really care. So my first query is to get where the continent equal to Africa. If I plot this one, filtered dot plot, passing my fixed size, you see that it only gives me the countries, the whole of Africa, all the countries. Great. But if I want to add another filter, what I have to do first is to wrap this in a pair of round brackets and then bring an ampersand. Then my next query or filter will also follow in a pair of round brackets. So that one is a GDF. We want it where the column name was population estimate, should be greater than 20 million. If I run this now, I will not see the whole of Africa because this the rest are chopped out, which are not more than 20 million in population. And so if I want a third one, all that I have to do is to bring an ampersand, and the third one will follow. Just like that. But I cannot, of course, put an empty query. So but I think this one should be explored rather. Okay. Taking some time to load. But you can see that these are the countries, all of them which have a population of 20 million and above, or above 20 million. Now, let's just say that we want to add another query to it. And we want, out of these countries, all the countries that contain, or let's say the ones that start with, and country starts with A, the letter A. So what I have to do is to add another query and say GDF, and then the name, that will be the name column. It is a string, but dot starts with, and I put in A. Let me run this and see. See that series object has no attribute starts with. So what we have to do is to explicitly tell the GeoPandas to treat each of the records as a string and not as a series. So, because we only have one item in there, so we can do this safely. So if we bring an str in front, then that one will work. Now we only have two countries, Angola and then Algeria. But we saw other countries in there. There were a lot of them. South Africa was there, Nigeria, there was Ghana, there was other countries, a lot of them in there. But because none of them starts with A, it did not work. So what we can do rather is to maybe search for contains. Actually, this did work. Let me raise that one. This did work because out of all of them, it's only the the Algeria and the Angola that starts with the uppercase A. But if I change it to str contains, then I think I have one more country added, which is South Africa, because the A in South Africa, the A in the Africa is uppercase A. But you also know that countries like Nigeria, like Ghana, they contain A, just that it's not the uppercase A. So what if you want to refine your query further to make it case insensitive? In that case, you just put the case argument here and say that the case equal to false. And that one will fetch all the countries that have A in their name, irrespective of whatever the A is and irrespective of whatever the case of that A is. And so by that, our query is refined. We can go ahead and nest other queries if we had more, just by adding an ampersand and then continue to talk to the data. So that is also how we perform the nested, or what I'll call multiple filter queries with GeoPandas. So the next on the list is to learn how to perform some geometric operations. We will look at the dissolve, the clip, and then the buffer. The dissolve is quite, all of them, to be honest, are quite simple with GeoPandas. So for this one, we want to now group the data by continent. So group by continent. It's quite easy. I can call this one GDF underscore dissolved because we have another GDF. I don't want to overwrite it. All I have to do to dissolve it is to say GDF.dissolve. And then inside here, I pass the column I want to use to dissolve it. So dissolve by continent. Continent. It looks like the most logical column we can use to do this dissolving, because all the others, I'm sure they are very unique. If we go GDF dissolve.explore, you will see that all of them, now the countries are not separated again. All of them, like, they have been grouped into the continent. So that is how the dissolve works. You just pass in the column that you want, and then it will dissolve it for you. The next one is the clip. Which kind of helps you to create a subset from a larger data set, if I should say it less technically. For this one, we will also explore a particular data set also as part of the ones that comes default with GeoPandas. I'll call it cities, and you will know why in a few seconds. I will say gpd.read file, and then in here, I want to read gpd.datasets .get underscore path, and then this one is called natural earth underscore cities. So I could have broken it down like I'll extract this one to a variable called path, but you can also pass it in directly. If I explore the cities, you see that it has only a name column and then the geometry column. So we cannot really place a filter on this to select all the cities in a particular continent if we wanted to. That would have only been possible if there was a continent column containing the respective continent in which the city is found. So what we can do to get all the cities in the African continent or any other continent of your choice is to clip it out. So we can plot these cities, or rather explore. And then it will show all around. I'm not connected to the internet at the moment. That is why my map is not loading. But if you have internet, you should see that it's now spread all across the world. And so if I go to the plots, maybe with the figure size, then I see something like this. Okay. Which is also not that great. But what we want to do is to clip out all the cities in the African continent. So we can do that by first getting Africa from the larger data set. Let me call it Africa. And you know how we can get it? This is a simple query. So that we call the GDF, and the GDF where the continent column is double equal to Africa. And so this will give us for the Africa continent, and then we can perform the clip. I'll call the new data set or the clip data set Africa cities. And that will be cities.clip. And then we specify the boundary or the clip extent that we want to use. And in our case is Africa. So when we explore this one, so Africa cities.explore, you will see that, once again, forgive me for my map not loading, okay. You see that it's only now the cities in Africa that are showing. All the ones here, you come just a little bit outside of Africa to this side where my cursor is, you don't see any cities here. We have been able to successfully clip out only the cities that are in the African continent. And that is how the clip works. You just have to get the data set you want to clip and then your boundary. Then you can clip it. The next one is the buffer. How we can create buffers around features. That one is also quite simple. Let's just say we want to create buffers around our cities. So we can say cities buffer. And that should be Africa cities.buffer. And when we call the buffer like this, we have to specify the buffer unit, the buffer distance. If I put 5, that means give me a buffer distance of 5 units, where this unit equal to the unit used in the coordinate reference system of the data set. In the previous tutorial, we learned how to explore the coordinate reference information for a particular data. So this one, if you explore the coordinate reference system, you know the unit for the buffer or any other data you are using. Maybe you're not using this GeoPandas data set, but if your CRS unit is in meters, then this 5 will be 5 meters. If it is in feet, then it will be 5 feet. So we can now plot this one. I would like to plot it, so that would be cities buffer dot plot. And then we see some very big circles. But one of the things that really let us know that this buffer worked is when we plot the points themselves on the buffer. And to be able to do that, I have to use subplots. So let me import PLT, the pyplot from matplotlib. So import matplotlib dot pyplot as PLT, and then I can say the figure, the axis, that should be equal to plt.subplot. And I want to pass in the figure size here. Because it's just one plot, I don't have to specify the number of rows and number of columns. It's just one. And so now I can plot the Africa cities, the cities buffer, sorry. And then here specify that the axis equal to axis. And then I can call my plt.show. I'll still see this one. This is a user warning saying that the geometry is a geographic CRS. So the buffer is likely incorrect, and that is true. We use projected coordinate reference systems for these, but for the purpose of this tutorial, I think we can do something like this. But for your data set, you should know that you have to project it into projected coordinate system before you use it, if it is not already in a projected coordinate system. And then we can nest another plot on this particular axis. We can stack it on it if you want to say so. That is the Africa cities themselves. So Africa cities dot plot. And then we can say this one to axis equal to the axis. But of course we will not see it, so we have to give another color. So we can say color equal to red. And then now we begin to see the cities and their buffer around it. You can even style it further by giving an alpha here, maybe of 0.5. That will make sure that the buffers are transparent for you if you want it that way. So that is also how to create the buffer around a particular geometry. This should work also for other geometries other than points. But of course, make sure that you are using a projected coordinate reference system to do that. Okay. Now, we have been using datasets from GeoPandas itself. I've been talking about a GeoDataFrame. But what if you want to create your own GeoDataFrame? How do you go about that? So it is quite easy. Let me give a title here. Creating a GeoDataFrame. So let's say point 1, point 2, and point 3, they are equal to, and now we are using the point that we imported at the top there, point 1, 1. The point 2 is also equal to point 2, 2. And then the point 3 is also equal to point 3, 3. If we want to create a geodata frame with this point, let me bring this one from my notes. So this is just the dictionary structure saying that there should be a name column which maps to the 3 points respectively. So point 1 is known as point 1, point 2, point 3. And there's a description column. I've shortened it to DESC because of the name length of column headings in a shapefile, but you can see that the 3 descriptions are also there. And this is the geometry column. This name is not random, it should be exact. You have to type the word geometry. And I'm also mapping these geometries to the points I have created at the top there. And just as you can easily convert a dictionary to a pandas data frame, you can do so with a geodata frame as well. If I call this one GDF new, I can say that is equal to GPD dot GeoDataFrame, and then I pass in the data I want to convert to the geodata frame. Now I can exploit to the GDF new, and then I have my geodata frame there. I can do all the things we have done with geodata frames with this one also. I can call the .info if I want to. I can call the .describe if I want to. So it is also a geodata frame, but for now I want to plot it, so the .plot. And then I see my plots over there. So that is it, how to create a geodata frame. But usually this is not how you will create it. except for simple text and use cases like this. You want to know how it is done. But you usually and most likely have your file in an Excel or a CSV, and you will want to convert it to a GeoDataFrame. That will not be explored in this particular episode. In the next episode, we'll look at how we can create files or vector files from other tabular data types like the CSV and the Excel. But for now, just for you to know how the GeoDataFrame is created if you want to create your own from scratch. We have been using data, we have been importing, we have been creating our GeoDataFrame. But what if you want to save the data ourselves? So for instance, we want to save our GeoDataFrame which we have just created. Well, that is also very simple. But before we proceed, let me show you that I have here, I've changed the structure a bit. So this is a bit different from what was pushed earlier for the first tutorial. Now I have inside the vector geoprocessing folder, I have a data folder and an output folder. Inside the data folder, I have folders for 001, 01, and those ones. I'm structuring it this way so that they will match the number that prefixes the Jupyter notebook. So if you are looking for all the data that I am using in a particular tutorial, just look at the number that prefixes the Jupyter notebook and you'll find the corresponding data or the corresponding output in this data and output folder. So what we want to do is that you can see now they are empty. The first one we created the shapefile, so the data is there, but for this one it's empty. The data is also empty. We are not using any data now. In subsequent ones we will use, but I just still want to keep the structure there even if there is nothing in it. And so what we want to do is to save files into this 01 output folder, our GeoDataFrame. This one should be saving file to different formats. We will save it to a shapefile. We will also save it to a GeoPackage, and we will also save it to a GeoJSON. So I'll call the output directory, which is equal to os.path.join. I want to join the current directory with the folder called output, and then inside it there's another one called 01 underscore output. But because shapefiles usually they come with more than one file, I want to keep the shapefile in a separate folder called shp. So I'll create that one specially for the shapefile shp directory that is equal to os.path.join, and then I want to join the output directory with a folder called shp. This one doesn't exist, so I'll say os.make directories, and then I want to make the shapefile directory, but I want to pass the exist OK flag to be true, so that the next time I run this and the folder exists, it will not throw an error. So if I run this one, it should create the folder for me, and that is nice. Now, what I have to do is to, let me get the file names. For the shapefile name, or let me copy this from my notes here. The goal is not for you to watch me type. This is the shapefile name, which is I'm joining the shapefile directory with a file called shapefile.shp. And for the geo package and the GeoJSON, I'm just putting them in the output directory, which is the 01 output here, with the names geopackage. But the extensions are very important, so make sure that you have them correct. Now, if I want to save the data, all that I have to do is GDF new, that is how what we called it, .to file. And then here I can see the SHP name. But I also have to specify the driver, which is the Esri shapefile. Please, this name is not random. The driver's name should be exact, otherwise it will not work. I can duplicate this line 2 times for the other ones, and this one I want to save the GPKG name. The driver here is GPKG. That is if you want to save to a geo package. And then the next one is the GeoJSON. And the driver here also is a GeoJSON. Please check how it is spelled. It is very important. It should be exact. Now, when I come here, I refresh the Explorer. If I come to the 01 output, you only see the shapefile there because we ran the cell once before, but there are no files there. So if I run it now again, and I open the same 01 output, you see that inside our SHP we have the shapefile, and then we have the geo package and the GeoJSON also sitting in the output folder directly. If I come to QGIS here, and then I've connected this, we did it in the last tutorial, I can go to my output, 01 output, and then load first the shapefile, the GeoJSON, and the geo package. And then here, if I inspect the properties of the geo package, come to the information side, you see that the storage is a GPKG, so it's a geo package. If I inspect for the GeoJSON also, you see that this is it. And for the shapefile also, I'll see that it's an Esri shapefile. So that is how we also save files. If you have a GeoDataFrame you want to save, that is how you save it. You just specify the file path with the extension and then specify the driver you want to save the file with. So that, my friends, is our introduction to GeoPandas. I hope you found it useful. If you have any concerns, you can put them down in the comments and I'll come and address it as quickly as I can. But if you like the series, just be sure to give it a thumbs up, and you can recommend it to your friends who you know also will need it. Thank you very much for sticking around up to this time. The link to everything is in the description and in the repository. So until next time, it is goodbye.